Hey, sixth grade, we're going to go ahead and tackle 9.4 areas of circles. Make sure you have your areas of circles notes, a calculator, and your book is open to page 398. All right, areas of circles. We are just going to go straight to the meat of the lesson, which is the formula for the area of a circle, okay? In order to properly work with this formula, we have to remind ourselves about one very important facet of a triangle, not a triangle, Mrs. Wilkening, a circle, okay? And the very important thing we need to talk about with the circle is the radius, okay? Is the radius. And really quick, I'm going to go ahead and change to a color that's a little bit brighter so that's easier to see, okay? Radius of a circle. The radius of the circle is a segment that is drawn from the center of the circle to the outside of the circle. The radius can go this way, the radius can go this way, the radius can go this way, okay? These are all radii, okay? Radii is plural of radius. My circle is really poorly drawn, okay? So it doesn't look like these segments are all equal, but every radius in a circle is the same distance, okay? When we are talking about area of a circle, area is equal to pi times the radius squared. Back in chapter 8, we talked about the circumference of a circle. When we used circumference, we were allowed to use either radius or diameter in a circumference formula. We had two different formulas. For area, we do not. We only have one formula, and it is always in relation to the radius only. That is super, super, super important that you remember that as you work through areas of circles. Okay, example number 1. Find the area of a circular flower bed. Okay, so it doesn't matter what it is. In this case, it's a flower bed. Find the area of a circle, okay, whose radius is 5 feet. So here we have our little pretend flower bed, okay? Our radius, so from the center to the outside of a circle, here's our radius, is 5 feet. Use 3.14 for pi. So all we're going to do is plug in what we have. We have pi, which we were instructed to use 3.14 for that. Do not just push the pi button on your calculator. Use 3.14 on your calculator for these, okay? So 3.14 times the radius squared. The radius is 5 squared. Order of operations is very important here. 3.14 times 5, and all of that squared is going to give you the wrong answer. Bad math. Make sure you are only squaring the radius. So it's really 3.14 times what is 5 squared. You should have that committed to memory. 5 squared is 5 times 5, not 5 times 2. 5 times 5, which is 25. When you plug 3.14 times 25 into your calculator, you get 78.5, and we have feet squared because this is area. So the area of a circle that has the radius of 5 feet is 78.5 feet squared. So all of this 5 feet radius flower bed, everything contained within that flower bed is 78.5 feet squared. Okay, skill check number 1. So box skill check number 1, I'm going to go ahead and tackle number 1 and number 3 in here. Okay, so number 1 just says, what's the area here? Okay, we have a circle that has a radius of 3 centimeters. So area is equal to pi times radius squared. We're going to use 3.14 in place of pi. So 3.14 times 3 squared. Okay, and that's actually this skill check number 1. Number 1 here was just to fill in the blanks, just to make sure you knew what you were doing here. So that's all you're doing for skill check number 1, number 1. Okay, box skill check number 1, number 3 says find the area of the circle and use 3.14 for pi. So we're given a radius of 6 centimeters. Plug into your formula. Okay, what is pi? 3.14. What is our radius? It is 6 squared. That is equal to 3.14 times 6 squared. 6 times 6 is 36. When you plug 3.14 times 36 into your calculator, you get 113.04, and our units are centimeters, so it's area centimeters squared. The area is 113.04 centimeters squared. If you want to tackle question number 4 in box skill check number 1, and you want to check and make sure you got the right answer, the answer to that is 19.625 meters squared. Okay? Moving along, we have to think sometimes of this formula, pi r squared, when we're given a diameter of a circle. So our formula only is to be used with radius. What do we do if we're given the diameter? Well, let's recall really quickly the relationship between radius and diameter. I'm just going to sketch a quick circle right here. Here is the center of the circle. Here is a radius. Here's another radius. What's the definition of a diameter? A diameter is a chord that goes all the way from one side of a circle to another through the center. Where did I just draw that chord through? I drew it directly through my 2 radii, okay? So 2 times the radius gives us the diameter of a circle, which opposite of that means the radius is equal to the diameter divided by 2, or another way to think about that is 1/2 times the diameter, okay? So 2 times the radius is equal to our diameter, or the radius is equal to the diameter divided by 2, or 1/2 times the diameter. So in example number 2, we are instructed, or it says, find the area of a circle with a diameter of 28 centimeters. So here's our diameter of 28, okay? Diameter is equal to, okay, 2 times our radius, okay? Or our radius is equal to our diameter divided by 2. So what is the radius of this particular circle that has a diameter of 28? Just plug in 28 for your diameter. 28 divided by 2 is 14. So the radius of this circle is 14. Now we have what we need to use our formula, which is pi r squared. Remember, our other approximation for pi that we use sometimes is the fraction 22/7, and that's what we're asked to use in this example. So plug in what we have. Okay, area is equal to pi, which in this case we're using 22/7. So pi times radius squared. We figured out our radius is 14 squared. You should have 14